Okay, the next part here is to apply this to stoichiometry in terms of chemical reactions. So I'm going to write a chemical reaction and take a look at it. So methane, combustion of methane. So here's the balance equation. All right. Now, all right, take a look at this. So the chemical equation, what it really represents is it represents a formula for a recipe. And it says that this is what you need. You need one of these, methanes, two of these to make one carbon dioxide and two waters. All right, and that's simple. That's, you know, what I tell my students is I just basically call this a chemical recipe. All right. Now I know it's not technically right in terms of the world of chemistry, but I'm going to do it regardless. It's a way that makes sense to me, and that's more important than following any kind of rules in there that don't have to be applied. Okay, so what we have here is, okay, first of all, these numbers here really does not mean you're going to take one molecule of methane, add it to two molecules of oxygen, you get one molecule of carbon dioxide and two molecules of water. What it really means is you're going to take a huge quantity, a mole, and add it to two quantities, mole of oxygen, and getting one quantity, mole of carbon dioxide, and two quantities, mole of water. So what this here means is that there's one mole of CH4 molecules per recipe for this reaction. Okay, and then you're going to do the same with this for oxygen, so there are 2 moles of oxygen per mole recipe, and so forth, okay? All right, well, if you look, what do we have here? We have another grouping triangle. We have, in fact, we have 4 of them. This guy right here, and I'll just do it for methane right now, is a, okay. So what is this, what are we going to group into? What is the groups? The groups are the recipes, or the whole equation. The grouping size is the moles per recipe, which in this case is 1 mole per recipe of methane. And what am I grouping? Okay, so we're just going to deal with methane. Okay, now let's just work through it. Okay, let's say I want to do 4 of these reactions. So I want to do 4 recipes. So I'm going to put 4 here. And what does that mean? I have to do, each time I do it, I need 1 mole per recipe, and I need 4, so I'm going to do 1 mole 4 times. Which is 4. So I need 4 moles to do 4 recipes. Let's try it with oxygen. So this is methane. All right, for oxygen, we come similar triangle, grouping triangle. In this case, it's 2 moles per recipe. And if recipes is what you're going to group into, and then moles. And so what I have here is, okay, so let's say I have 10 moles, and I want to know how many recipes, or how many times I can do the reaction. So I give myself 10, and what I'm going to do is each time I do the recipe, I need 2, so I'm going to divide this up into groups of 2. Groups of 2 mole per recipe, and I will end up doing 5 recipes. Okay. So what we can do is we can use this grouping triangles to help us in stoichiometry. So let's write write it all out. So CH4 plus, need a lot of room here. So CH4 plus 2O2 yields CO2, one of them, and then 2H2O. So each substance gets its own grouping triangle based on its moles per recipe. So this is 1 mole per recipe. Let's just put it here. So the middle column is moles per recipe, how many moles you need, then recipes, and then moles. So the number that you use here is the coefficient. You need to have 2 moles per recipe, you need to have 1, and you need to have 2. All right, so I'm gonna do a couple of these problems and see how they work. Okay, so let's say I wanna do 3 recipes. So what I'm gonna do is start out with 3 times. I wanna do it 3 times. Okay. Every time I do it, I need 1, and I do it 3 times. Isn't that great? Okay. Every time I do this reaction, I need 2 oxygens, and if I do it 3 times, I need 2, 3 times, 2, 3 times, and I'll get 6. For carbon dioxide, I need 1. Every time I do it, I'm going to do it 3 times. So I need 3. And for water, and every time I do it, I need 2 moles. And I do it 3 times, and I get 6. Okay, so I'm going to do 2 3 times. I do 1 3 times, and I'm going to do 2 and 1 3 times. Okay. So if I want to do it, that just makes sense. It's like cooking. All right. Rewrite the triangles just because it's a bit messy here. The number I put in the middle never changes for this reaction. It tells me how many. All right, so this next one, what I'm going to do is I'm going to start out, I need to start with 5 moles of CO2. And what I want to do is how many recipes and the number of moles of everything else. Okay, so I'm going to start right here. Okay, so what I can do now is I can figure out how many recipes 5 moles of carbon dioxide I will make. Okay, every time I do the recipe, I need 1. I have 5, so I can divide 5 by 1 and come up with 5. So I can do the reaction 5 times. So I'm going to bring the 5 all the way across to find out how many moles of everything else I need. Okay, I do it. I need 1, do it 5 times. Got 5. I got 2, I do it 5 times. I got 10. Okay, I got 2 again, do it 5 times. I got 10. There you go. So I can figure out how many moles I have. If somebody gives me a certain amount of moles, I can figure the rest of the moles. Okay. Okay, next thing I'm going to do is I'm going to combine now this with molar mass. So I call these the recipe triangles. Okay, so recipe triangle is you're grouping in the recipes. Now, the other grouping you can use here is the molar mass triangle. All right, it's where you have grams per mole, moles, and grams. You notice these two guys are the same. So whatever thing you get here is the same as you have here. So I'll do an example of this. Okay, first thing I need to do is I need to figure out the molar masses for each one of these. Okay, what's a molar mass? So molar masses. And we're just going to use whole numbers to make things simple. Molar mass is, my thing is 16. Don't use the coefficient. So it's 12 plus 1 plus 1 plus 1 plus 1. 16. This is 32. 2 16s. This is 44 grams. And this is 18. Okay, so I'm going to put those in the grouping size. And I also will have to put my moles per recipe. Okay, so what I'm going to do is I'm going to start out with a certain amount of recipes. Okay, let's say I want to do 4 recipes. I'm circling what I'm going to start with. What I want to do is I want to figure out how many grams of everything that I'm going to need to make. Okay, I do it 4 times. Each time I do it, I need 1 methane so I can make 4 moles. So I'll go all the way across. I need 8 moles. 4 times 2, 4 and 8. Okay, so that's how many moles I need. Well, I'm going to bring it down here because these numbers are the same. Okay, let's start over here. Each methane weighs 16, and you have 4 of them, so it's going to be 16 4 times, and that's going to be 64 grams. All right, this guy over here, oxygen, you need 8 of them. That's 4 times 2. 2 times 4 is 8. Each one weighs 32, so you do 8 32 times, and you get 256. All right, carbon dioxide, each carbon dioxide weighs 4. You do that 4 times, then you get 176 grams. And for water, you end up getting 144 grams. You do 18 8 times. Okay, there you go. And if you look, 64 plus 256 equals 176. It's 144 for this conservation of matter. Okay. What I am going to do now is I'm going to clean this up a little bit. Have to use the same ideas, but I'm going to make it more of a chart form, just the easy word. Combine. Make it easier to see. Okay, so instead of drawing triangles, what I'm going to do is I'm going to draw a chart. Okay, so here's my first one. Recipes, moles, recipes, and moles. Okay, my other triangle, the molar mass, is actually incorporates this guy here. So I'm just going to add 2 more columns, rows. So I have my recipe triangle, and I have my molar mass triangle. Grams per mole, and then grams. Okay, put all the same numbers in here. Okay, this column here is my coefficients. This column here is my molar mass. Coefficients molar mass. So 1, 2, 1, 2. So these never change for this chemical reaction. Again, this is 16, 32, 44, and 18. All right, so let's do a hard one. Okay, what kind of hard? So what I'm going to do is start out with 480 grams of oxygen, and I want to know how many grams of water I'm going to make, assuming I have the ethane and methane in excess. Okay. So I got to figure out how many recipes. You always got to figure out how many recipes you get. So you take 48 divided by 32, and you're going to get 15. So that's 50. So there are 15 moles. Okay, every time you do this reaction, you need 2 moles. If you have 15, all you can do is 7.5 times. So you divide the 15 up into groups of 2, you get 7.5 times. All right, come over here. Bring the 7.5 over here. And what you got now is you're gonna make 15 moles. Every time you do it, you do 2. Do 7.5 times. You get 15 moles. And then you multiply, well, every time you do it, you need 18, and you have 15 of them, and that's 270 grams. So you start out with 480 grams of oxygen, you will end up with 270 grams of water. Now, if you would like to check your answer, what you could do is you can find this value here and this value here, and if the sum of these two numbers are equal to the sum of these two numbers, you got to check there. How about that? So stoichiometry, what you do is you basically set up your stoichiometry grouping trying to your table. As such, okay, these are going to be your coefficients, and they never change. And these are your molar masses. You're always dividing up into groups. You always go from grams to moles. You divide the grams up into moles to make moles, find out how moles you have. And if you moles, you need to figure out how many recipes those moles can make. So whenever you want to go up, you divide up into. Okay. Whenever you want to come down, you multiply out of. You always want to aim for getting your recipes first. So whenever you're down here and you want to get over there, what you have to do is you have to figure out how many recipes. So if you have grams, you have to figure out moles, that is. Then you have to divide those moles up into the moles per recipes, figure out recipes. And then you can figure out the rest of the table. There you go. Pretty straightforward. And then what we can do is we can tie this all in with conversion factors as well. For that case, to do the conversions, okay, so let's do the conversion of the one we just did. Okay, so I have 1, 2, 1, 2, and put down these numbers here. 16, 32, 44, and 18. Okay, so I started out with, what was it, 480 grams, 15, 7.5. Bring the 7.5 over here. 15, and then 270. All right. Okay, using conversion, like I said in the last, is I take 480 grams, I'm going up, so I'm going to divide by, multiply by the reciprocal. And this is grams of O2 and grams of O2 per mole. Okay, then I go up again, and this is going up through, so it's 2 moles per recipe. So I'm going to flip it, O2, and then I bring it over here, and I go, this is my operation, so I'm going down, so it's 2 moles of water for 1 recipe, and then I'm doing 18 grams for 1 mole of water. Okay, so you just write down, these are the operations. So when you go up, you use the reciprocal. Okay, so the reciprocal, instead of 2 over 1, it's 1 over 2. When going down, you keep it, and 2 over 1, and then 18 over 1, and you get 270. All right, next one, I'll do a couple of more examples on this, and to see, just do some practice and also display the triangles.